Welcome to Saxon Algebra 1 3rd edition, lesson 82. This lesson is on evaluating functions and domain and range. Okay, let's start with evaluating functions. Here you see f of x equals 6x minus 1. We read that as the function of x is 6x minus 1. Okay, and then it says, so if that's the function of x, find the function of 5. What you're going to do is you're going to replace 5 everywhere you have an x. So right here we would put a 5 in parentheses, and we would work the problem. 6 times 5 is 30 minus 1, so the answer is 29. So we're basically replacing whatever it says that the function of f is for any x's in the equation. Here's another way to think of it. The old way that we have been using is what is y equals 2x if x is equal to 5. And you've been asked to evaluate that, and you know that you just replace the x with a 5. Okay, the new way using function notation says the f of x equals 2x and the function is 5. So then what would it be? We say 5 here is the input and 10 is the output. Okay, and we'll get to a little bit more of that in a minute. You can see here we've done the same thing. So if you want to think of it, you're replacing the y that we're used to with function, the f of or the g of, or few letters are used to designate function. Okay, some problems that we can work. If f of x is x squared plus x minus 10, meaning that's what it does, then find the function of 5. So everywhere we have a x, we're going to replace it with a 5. So if f of 5, and we replaced this x right here, equals x squared plus x minus 10. Then the function of 5 is 5 squared is 25 plus 5 minus 10, and the function of 5 is 20. Another way that you can think of this, and we'll talk a little bit more when we talk about domain and range, is if we had a function machine, and inside the function machine, this is the operation that's going to take place. And this is the number we're going to put into the machine, and this is the number that would come out of the machine with this going on inside. Okay? This one says if h of x, same thing, you still read it the same way. If the function of x is x squared plus x plus 1, find the function of a squared. Now here we don't have a number to replace it with. We have a variable. We still do the same thing though. Instead of x here, we're going to replace it with a squared. And remember, that's going to be squared also because we're using parentheses here. Plus a squared plus 1. Well, then the function of a squared is a squared squared, which is a to the 4th, plus a squared plus 1. If this is the input and this is the function that happens, then this is the output. All right, now here, this is a little bit different. This says find the domain of the function of x equals the square root of 5 minus x. Now, x cannot be negative in the radicand, so we have to take it out of this radical sign and treat it as we do in an equation or an inequality. So we say 5 minus x is greater than or equal to 0, and we move the x here. We're going to add x. So we have 5 is greater than or equal to x. So putting it in standard form, we could say that x is less than or equal to 5. Now, function notation, this is how we would set this up. X is the domain and y is the range. So this is an x problem, so we're dealing with domain, and we're going to write it like this. The domain of f is, this is how you read this. X is a member of the set of real numbers such that, and then you put in what we had here, your outcome. X is less than or equal to 5. You can find this wording in your book, but I'm just trying to make it a little bit plainer for you. All right, this one is also a little bit different. It says find the domain of the function of x equals 1 divided by x. Now we want to find the set of all acceptable values for x. And notice that g of x equals blank has, that the function of x equals 1 over x has a value whenever x doesn't equal 0, because you can't have 1 divided by 0. Therefore, the domain of g is x is a member of the set of real numbers such that, such that x is not equal to 0. In other words, any other number will work there for x, but 0 will not. So all the real numbers except for 0. Okay? Now I've already hinted at domain and range and told you a little bit about it, but basically domain, here's your function machine. Domain is the x that you're going to put in, and range is the y or answer that you're going to get out if you put x in. To determine the domain of all possible x values of the quadratic function, look for the leftmost and rightmost x values on the graph, and determine the range of all possible y values. You're going to look for the lowermost and uppermost y values on the graph. Okay, let's look at that. All right, here you've got, this is called a parabola, and you'll get into that a little bit more in your next book, but we see that the graph continues up towards the left and towards the right, and the domain contains all real numbers from negative infinity to positive infinity. So the domain of this would be negative infinity, x is greater than negative infinity, and less than positive infinity. Or we could say it is all real numbers. X is a member of the set of real numbers. Okay? And here, since the minimum y value of the function is 0, 0 is the lowest point. It comes on the y-axis. And the graph continues to extend upward, and the arrows indicate it's going to continue to go upward. Then we can say that the range is greater than or equal to 0. So all real numbers that are greater than or equal to 0. All right, this says determine the domain and range. All right, in this line, the domain, and domain is x, so you want to look at the x-axis, left to right, it goes from -3, and this is an open circle on -3, to a closed circle on +2. That is the range. So we would have to say the domain is x is greater than -3, but it is less than or equal to +2. Then the range, we can see that it goes from 5 at the top to -5 here at the bottom. So we just, for range, we do the very same thing, except we put y in the middle, and y is greater than -5, but is less than or equal to +5. All right, let's look at this one and see if we can determine the domain and range. All right, so the domain, where it touches x, it only touches right here at this one point. So the domain is x is equal to 0. But the range is up and down. And we can see that the bottom, the lowest point it goes is -4. And we'll say it is equal to, because that looks like a closed circle. And +7 is the farthest it goes on the right. And we'll assume that there are dots there. But you can see how I did that. I went from 7 to -4 for the y. And for x, I only had one value of x, and that was here on 0. So again, the range is all the y values possible, and the domain is all the x values that are possible. In this kind of equation, right here, we can see that the we have all real numbers. But in this one, y is only equal to 14. That's where, on this graph, that's where it lies. So let's do our practice problems. Going back to the functional notation, if the function of x is 2x squared plus 3x minus 5, find the function of m squared. So here, here, and here we're going to replace with m squared. So 2 times m squared squared plus 3 times m squared minus 5. Alright, well when I square m squared, I get m to the 4th, and that's, so I multiply this 2, I get 2m to the 4th plus 3m squared minus 5. That would be my output if this were my input. B says if the g of x is, which is still pronounced function of x squared minus 4, then find the function of m plus 2. So that means we're going to put m plus 2 right here. So we have m plus 2, we're going to keep it in parentheses, that's important, squared minus 4. When we square m plus 2, we get m plus 2 times m plus 2. When we do FOIL, we get m squared plus 2m plus 2m, which is plus 4m. And then we get plus 4, 2 times 2 is 4, and then minus 4. When we simplify that, we're left with m squared plus 4m as our output. Okay, and C tells us to, if the function of x is 3x, find the domain and range of this function. Okay, so we could say it is y equals 3x plus 0. We're going to graph that. So we're going to start at 0 and go up 3 over 1, up 3 over 1. And we could also go down 3 from our um, origin and over 1. And then when we connect these dots, we're going to see that this is a single line that continues in both directions. It can continue going on the x-axis, 3 over 1, and it can continue going on the y-axis. So basically, we're going to say that the domain equals the set of all real numbers and the range also is going to equal the set of all real numbers. And that's how you would denote that function. So on this one, if the function of x equals 2, find the domain and range of the function g. All right, well, if it equals 2, and this means y, then that means y equals 2. And we would graph that just like this. And it goes on for basically infinity in all directions, so the domain, or the x values, is going to be the set of all real numbers, because it can continue to go on and on, all real numbers. However, you can see that it does not go any higher or lower than 2. So for range, we can say that the range is 2. And that's its only range. Okay? All right, on this one, it asks us to choose the domain and the range of this graph, this function. Okay, so domain we'll do first. It is x. So across, we go from here to here. This is at the lower end, and it is, let's see, -1. And it is an open circle, so we're just going to put is less than x. And over here, we've got 5, and it's a closed circle, so x is, x is less than or equal to 5. All right, for range, we are going from lowest point to highest point. Our lowest point is here. Our highest point is here. Okay, we can draw this little box. So, y is a member of all the set of real numbers such that, that's what that means. I'm going to put my y in the middle. I'm going to do this, this. And both of these are closed circles, so I can go ahead and put my line under both of those. The bottommost point goes first, and that would be -1. And the top would be 3. And that is how you're going to have to write that. Finally, find the domain and of the function of x equals the square root of 3 minus x. And we remember that we can't have a negative x. So we're going to have to take that out, and we're going to have to say 3 minus x is greater than or equal to 0. And then I'm going to have to move that x to the other side, so plus x. So 3 is greater than or equal to x. And so when I say the domain would be x is a member of the set of real numbers such that x is less than or equal to 3. If you have problems like this in the days to come, and you will, simply look back. You may want to dog-ear this page. It is page 339 that shows you how to do this, and just go from there until you get the hang of it. Good luck. I'll see you back next time for Lesson 83.